Welcome on this new course on predictive analytics and what is a data scientist. A data scientist has been described as the juncture between three types of skills. First, hacking skills, then math and statistics knowledge, and finally substantive expertise. So first, let's start about math and stats knowledge and why are data scientists supposed to be mathematicians, or at least good at math and good at statistics. If that's the case, why don't we just call them statisticians or analysts? Well, there is a big difference. Actually, data scientists, the one that basically create value from data, need to be good at math and statistics. That's really the foundation of their capabilities. You need to know the basics of these disciplines in order to manipulate data and find information in it. But what I like to insist in is the fact that using math and stats for data science goes actually beyond the regular math and stats that you would learn at university. The difference is that you use these tools in a different mindset. You are not So when you have a data set and you try to, let's say, predict something from it, or you try to categorize the data set into different parts, the tools that you're going to use are not the ones that try to explain the data in a causal sense. You are not trying to find the fundamental laws that explain what drives what in the data. You are just using all tools at your disposal to achieve the goal that you have. So if you are looking for a prediction, so you have a data set and you try to predict the behavior of the next customer from it, or you try to predict epidemics, or you try to predict turnover or revenues. What you have to do that is the classic tools of statistics, but you also have anything that can solve the problem, for example, with algorithms. So maybe you won't find a neat equation or a neat formal model from statistics that will give you an answer, but simply running an algorithm that you drew from biology or that you drew from physics might just find the proper answer. And maybe that the statistical model that a professor would use would have been the formal solution to actually use, but maybe that this formal model was hard to scale, or maybe it was slow to compute. So again, data scientists use, of course, math and stats, but they are not bound by the formal tools that you would find in a textbook. They really pick anything that they can find from different disciplines, very much from computational computer science, to advance on their problem. The second skill that makes a data scientist is the hacking skills. And I think you understand from the previous slide what I mean by that. I mean that there is no recipe from university or from statistics courses that will instruct you how to analyze a data set. Each data set is a bit different, is a bit messy, is a bit domain specific. So in order to make the best of it, you have to have the spirit of somebody who thinks outside of the box. You have to be ready to look at textual data in it. You have to be able to do some network analysis if relations in the dataset are meaningful. And you have to be ready to get your hands dirty with the data, because maybe the data is actually not in the convenient format, or maybe the data should be integrated with another data source. And that will be your job as well, as a data scientist, to handle all of these issues. So you're not like the pure statistician in universities. Again, you are a bit of you have a can-do attitude. And then finally, what makes a data scientist very good at what they do is the fact that they get in touch with the reality of the domain they are analyzing. It means that very often the things that will help you boost the accuracy of your model are these are rules that, again, do not come from pure math and stats, but rules that you can try because you know that they would make sense in the context. So, for example, I participated in a competition on Kaggle. We'll see that in another slide deck. Which is Kaggle is a website for competitions in machine learning, and the exercise was given a data set of relations between individuals. This data set, some relations have been deleted, and the exercise, the challenge was try to guess the relations that were deleted between individuals. And I tried very hard on this competition. I was far from being the best. But one of the things that boosted the accuracy of my model and the rest of the others was a simple rule that didn't come from statistics or else. It was simply the fact that if you were seeing a relation between A and B, well, you just think of Twitter or another social network where people follow each other. If you were seeing seeing a relationship from A to B, then you had a very good chance that B would follow A. And again, not because any equation would dictate that, but just because you know how social networks work. And that's a very good thing to try, that if you see from A to B, then maybe that a link exists between B and A. Not always, but more than chance. And this thing, you know you can try that because you know how social networks work. So that's the case for social networks, but for any domain that the data relates to, banking, finance, marketing, culture, anything, you have to know the domain quite well in order to, again, achieve high accuracy in the exercises that you conduct. So to summarize, what does a data scientist look like? It's somebody, first I would say the most important, the key actually is that it should be somebody who is able to discover interesting angles in the data set. So somebody basically who thinks creatively, somebody who's not driven by recipes, but somebody who can think by themselves on the data set depending on the context and suggest models to apply or algorithms to try. That's a very creative step. then that's also somebody that is able to draw from their culture, from different academic disciplines, in order to apply analytical tools to the data sets. And nowadays, as I said, these tools do not come from a single textbook in statistics. You have to be curious about what's happening in neuroscience, where a lot of computational models are being developed, what's happening in econometrics, what's happening in statistical physics, what's happening in marketing. In all of these different disciplines, you have interesting new developments that would help you in a different context. And finally, a good data scientist should be curious, should have a culture of all recent developments, and a good data scientist should be able to implement their solution, because data scientists need to, they are kind of one man or one woman orchestra. They have to, for example, if they find a very good algorithm described in the literature, it's not very easy to find a programmer that will understand the logic of this algorithm and translate it into code. The data scientist most probably will have to do it themselves. And with all the issues that big data can open, such as is the algorithm going to run on a big data set? Is it gonna can you write it in the programming language of your choice? Is it going to run in minutes or hours or days, but not weeks? All of that should be at least understood by the data scientist. So I'm not saying that one data scientist should be able to do all of that, but all these skills should be present in your team of data scientists. So, as you see, data scientists are quite a rare beast. They are very high-profile analysts. Where do you find them? My suggestion would be that you would find them where you would detect talents, where these talents are most commonly expressed. On Stack Overflow, you would find individuals who contribute or discuss coding problems, and so that's Stack Overflow is a big website where people discuss the issues that they have in their programming language, like the bugs they have or the problems they can't solve. And these individuals, you can, and you have a reputation system on Stack Overflow that tells you who's very active on the website, who's contributing a lot. So on Stack Overflow, you can easily find individuals that make excellent contributions in the field you'd like to recruit. GitHub is another place where you would find talented individuals. GitHub is basically a free website where you can upload the code that you use, and individuals that contribute to open source projects very often upload their code source on GitHub. So you would find, if you find the code that reveals talent, well, you could just find related to it the author of this code and chase them for recruitment. And finally, specialized communities on Twitter. As far as I'm aware, data scientists are quite chatty on Twitter, and discuss a lot what they read, what they produce, the conferences they attend. So it's easy to spot at least the crowd of data scientists on Twitter, and then find the ones that reveal the most active and talented profile. And finally, don't neglect PhD students. PhD students who are near completion, they are the ones who are, well, ready to enter the job market, and they are, well, very talented as well. So when you have found a potential recruit for data science, it doesn't mean that they will choose to join your company. What you should try to increase your chance of recruiting them is making room for their personal development. So offer them free time on their working days, on their working hours, free time to develop personal projects. So for example, Google, you might be aware of that, offers 20% of free time to their most talented developers. So that's basically 1 day per week where Google employees can work on projects of their own. That's not completely wasted for Google, of course, because very often the personal projects that these employees choose to work on, these personal projects, they are very often related to the company's core activities anyway. So that's interesting. And allow them to attend conferences and meetups because they need that to develop their potential. And in any case, if you don't give them that, they might just leave your company for another one. So yes, and while the basic philosophy is as a company, if you want to nurture and keep data scientists, that you should not treat them as executioners of your strategy and of your business. They are co-developing your business, because data science, I think you understand by then, is really not just about finding automatically pieces of information in the data. It's about revealing the potential for value creation in the data sets. And they might be, these data scientists, they might be at least as well positioned as you are to suggest ideas and venues for revealing data in the for revealing value in the data set. So do treat them as co-business developers. That's it for the profiling of data scientists. Thank you.